sorry about that. I got a phone call. Alrighty. So, part 2 here, picking up where we left off. Okay, so again, we're looking at integrals. So we've got the integral of 2x cubed dx. Okay. Now again, that 2 is just a constant, so the 2 is going to come along with us, and then we're going to have x to the 4th over 4, right? Now in this case though, we can do a little simplifying. So yes, if there's simplifying, for sure, go ahead and do it. So we get cancel, cancel. So we end up with x to the 4th over 2 plus c. Okay. All right. So those are the basic guys, okay, the ones that we will use most often. Then we have, where am I now? The next rule, it looks like this. If we have the integral of f of x plus g of x dx. Okay. So this would kind of be along the lines of like a polynomial. Okay, so you've got 2 parts or more parts, like a polynomial has different terms. Then we can write this as the integral of f of x dx plus the integral of g of x dx. So it basically says that if you've got addition or subtraction in the integral, you can split that up and just do it piece at a time, which is fantastic. So it means that you can just go through a polynomial and take piece at a time. Now, like I said, that also works for subtraction, so we'll just slap a little subtraction sign in there so we don't have to write the whole thing over again. Okay, so let's see an example of this one. So there's our rule, and our example looks like the integral of 3x to the 5th plus 4x to the 3/2 minus 2x to the negative 1/2 dx. All right. So, not the prettiest thing, but I'm trying to get you to practice here, so we'll go with this guy. So the idea is we have 3 parts here. We can strictly just go boop, 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 and work our way right down the line. All right, so every one of them has a constant multiple out front. So like this first one, we're gonna put the 3 out front. Then this is gonna go x to the 6 over 6. Okay, then this is going to be 4 out front. Now this one's going to be x to the 5/2, right? Add 2 over 2 over 5/2. And now this one minus 2. And if we add 1 here, this is going to be positive 1/2 over 1/2, right? And we made it to the end of the list, so we'll just put C. Okay, now again, as we said, never, 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 never leave it like this. This will not cut it for me. So we definitely want to go through here and do some simplifying. So here we have 1/2 x to the 6th, right? Okay, here if we flip and multiply, we're going to have 8/5 x to the 5/2. Then minus, again, if we flip and multiply, we'll have 4x to the 1/2 plus c. So the other thing about antiderivatives that you need to become aware of and okay with right off the bat is that you are definitely going to have fractions, okay? Most definitely going to have fractions. And you just kind of have to get used to it. It's not the prettiest thing. Sometimes they will cancel out nicely, other times they do not. So you might as well get used to it now. Okay? But the nice thing again is that you can just simply go through term at a time and just boop, 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 take the antiderivative of each one. Okay, now 2 more rules. We've got the integral of e to the x dx. Now remember, this should be fresh in your mind, the derivative of e to the x is just e to the x, right? So guess what the antiderivative of e to the x is? still just e to the x. Okay, so this is still e to the x, but remember we have to follow this with a plus c. Righty. So that one's your nice one. When you see that e to the x, you're like, oh, thank God, e to the x. It never changes forward or backward. Okay? And then the last rule that we have here is the integral of 1 over x dx. Okay. Another way that you can see this written is if we flip that up top, the integral of x to the -1 dx. Okay, this one, even though it's actually a very simple antiderivative, it's the one that most people screw up because they see it in this form and they think, okay, I'm going to add 1 and divide by that new number. So when they go up 1, what's your new exponent? It would be 0, wouldn't it? And then divide by 0, does that make sense? Okay, it doesn't, and that's because this guy is different. So remember, you ask yourself, who had a derivative of 1 over x? And hopefully it's fresh because we just did it. So the antiderivative here, okay, is the ln of the absolute value of x. And then don't forget your plus c. But remember, ln of x, or ln of the absolute value of x, gave us a derivative of 1 over x. So when you see the 1 over x, you've got to remember that, oh, that's the ln of x. That's the antiderivative. Okay, and like I said, this is the easiest one to screw up on. More people screw up on this one than all of the others combined. Okay, so you gotta watch this one. Watch it. Okay, so what do I have on the back page? Okay, so we've got our basic rules then, and other than bringing in fractions, the rules are not too bad. So we have, notice though that every single time I ask you to do one of these integrals, or this indefinite integral, the reason why we call it indefinite is because are we 100% sure of the answer? Okay, in any of the situations, what did we put at the end of our answer? Plus c. Did you know what the c was in any one of these answers? Or even if there was a c, maybe there wasn't a c. So these are indefinite because we don't actually have a perfect answer. We have an answer plus c. So what we need to do is we want to take a step to kind of start figuring out what's going on here. So these next problems that are given are called initial value problems. Initial value problem. So this says, find the antiderivative. Actually, let me write this. Let me write it a little bit different. Find f if f prime of x equals 3x squared minus 4x plus 8 and f of 1 equals 9. All right, so an initial value problem, they're giving you the derivative, okay? They're giving you the derivative and they want us to go back and find the original function, but they've given us a little bit more information. They've given us an initial value. They're telling us when x is 1, the function is 9. And we're not going to use that yet, we're going to use that at the end. But we're going to start with our antiderivative and we're going to use it to build our function. I'm sorry, we're going to start with our derivative and we're going to use it to build our antiderivative or our function. Okay, so 3x squared, okay, if we go backwards, that'll be x cubed over 3, so the 3 is going to cancel, right? So that guy is just perfectly x cubed, which is nice. This guy, we're going to go minus 4x, the new exponent will be 2, right? It was a 1, so now it's a 2 over 2. And then this one, remember if it's just a constant, we're going to slap an x on it, is going to be 8x. And then we're going to hit it with the plus c. Okay. Now, we have more to do with this guy, so we want to do some simplifying here. So we've got f of x is x cubed minus 2x squared plus 8x plus c. Okay, now we are going to use this initial value. We know that in the original function, when x was 1, the answer is 9. So that means that I can plug in 9 for the answer when I plug in 1 for all of the x's. So 1 cubed minus 2 times 1 squared plus 8 times 1 plus c. And if I am able to plug all of that information in there, the 1 and the 9, can we solve this out to see what the c actually is? Okay, so here we have 9 equals, and the nice thing is it's a 1, so it doesn't really affect anything. So 1 minus 2 is negative 1, plus 8 is 7. So we end up with 7 plus c. So if we subtract the 7, we get a c equal to 2. Okay? And now, I ran myself out of room, of course, but now the last step is that we can now write the actual antiderivative. So now we know f of x is actually equal to x cubed minus 2x squared plus 8x plus 2. So in place of that c, we're putting 2. So this was the actual original function, okay, the actual original function, and we are able to replace the c. Okay? So let's look at another one of those. Let me find another one of those. Initial value. Or not, maybe? Are you kidding me? Where are they? Oh, that is so weird. Okay, so let's see what we got here. What if, well, let's look at this one. So find f if f prime of x is equal to the square root of x plus 2x, and f of 4 is equal to 25. Okay, so again, they've given us another initial value, but we're going to work with that later. So first we've got the derivative, and we want to find the antiderivative. So first thing I'm going to do again is rewrite. And then you got to get into your mind that, remember, we're going backwards. We're finding the antiderivative. Okay, so f of x. Make sure you give it your labels. Okay, the labels are very important because they tell me when you're doing what. Okay, so this is going to be x to the 3 halves, okay, over 3 halves, or could I just say multiplied by 2/3? Okay, so x to the 3 halves over 3 halves, which is the same thing as multiplying by 2/3. And then this guy, that's the perfect derivative of x squared, isn't it? Okay, x squared, and then plus c. So, you know, not the most gorgeous thing in the world, but we'll deal with it. That's the way life goes. Okay, we do have to do a little bit of work with it. So we know this time if we plug in 4, okay, the answer should pop out to be 25. So if the answer is 25, if we plug in 4, we get 4 to the 3 halves plus 4 squared plus c. Okay, so 4 to the 3 halves, 4 cubed is 64, and then the square root of 64 is 8. So we have 25 equals 2 times 3 times 8. Oh, I guess I could have put that together, but I won't. Plus 16 plus c. Okay, so keep going. So 25 equals 8 18, brain is not working today. 16 thirds plus 16 plus c. Okay, so let's move some things around. So if we subtract the 16, we'll now have 9 equals 16 thirds plus c. Okay, and 9 would be 27 thirds. So 27 thirds equals 16 thirds plus c. So if we subtract the 16 thirds, we should end up with 11 thirds. Everybody agree? 11 thirds equals C. So this is just to show you that you can actually get ugly answers too. They're not all going to be pretty, but you can do it. Okay, we can do it. So we can now say that our actual function is going to be 2 thirds x to the 3 halves plus x squared, and then it's going to have a plus 11 thirds hanging on the end. Alrighty. So remember, if they don't give you this initial value or it's in integral form, you always have to follow it with that plus c. But if they give you this, are you going to figure out what c is and finish the problem? So now does it become clear where I missed a point on my test because they gave me an initial value and I still put plus c? Not smart. Okay, blew it on that one. Okay, so just a couple more because there are some weird ones that I don't want you to get freaked out. I want you to think about before you do them. So let me look at a couple weird ones here. Weird ones. Alrighty, what do we got in the way of weird ones? Okay, let's look at this one. Okay, so on this one, actually, they're not only are they making it weird looking, but they're also changing the variable on you. Okay, so they've given us the integral of t squared plus 2 over t squared dt.